Hey everyone, and welcome back to the YouTube channel. If you're new here, my name is Emil and I graduated from high school in 2020. And today I'm going to be doing the VCAA 2018 Methods Exam 1 paper. I'm just going to be going through it, answering each of the questions, hopefully getting them right, and just explaining my working out for each of the questions. I hope this is helpful for you guys, especially if your teachers didn't explain a concept properly, or if you just want to see the sort of working out that you need to be doing to get the full marks for each question. If you appreciate the fact that I'm actually doing one of these methods papers a year after I've graduated, do hit the like button on this video or consider subscribing to the channel, as it would help me quite a lot. More importantly though, I know that the class of 2021 has had a very tough year, so this is my way of showing you guys some support, and I know that the last 2 to 3 months of year 12 can be very, very difficult, but I promise that most of the time when you push through, it is definitely worth it in the end. However, even though I've said that, do make sure to prioritize your mental health, especially when we're in lockdown and you can't see your friends or go to school. With that said though, let's get started. And I'd just like to say that before you watch this video, I'd highly recommend that you actually do this 2018 VCAA paper, just so I don't spoil this paper for you, or that you do it and you already know all the answers to it. All right, so I've got the methods paper here on my OneNote, and I've got my Surface pen that I can write on the screen with, so we might as well just get started. So this first question is basically your classic derivative question. You almost always get this as the first question on your methods paper, and it's also 1 mark, which means that I don't need to write much working for this question. So this one, I'm going to be using the chain rule. So I've got my derivative dy dx, then I've got the 3 here, so 3 times the derivative of the inside, which is going to be 9x squared, 2x, and then multiplied by the whole thing. And this is essentially your answer. I'm not going to write too much more than this. I might just remove the multiplication signs, and there's no point wasting any time trying to expand this because it's only worth 1 mark. So the next question, question 2, is worth 2 marks. And again, this is pretty much a differentiation question, but there's also a substitution bit which is coming from the pi. So with this one, this is going to be the quotient rule, and I can never remember the quotient rule, so I also downloaded the formula sheet here, and I'll just show you how you can use the sort of quotient rule. You can use the formula sheet to find the quotient rule. So here you've got the quotient rule in the formula sheet, and it tells you that ddx of u on v equals this. So I can just use this essentially to get the answer to part B of this question. So from that, I remember that f dash of x for this equation is going to be e to the x times cos x minus e to the x times negative sine x, which is the derivative of cos x, and then this is all going to be over cos squared of x, and then I can just simplify this as well again to get e to the x cos x plus sine x on cos squared x. And then all I have left to do is really just to sub in pi to get the answer. So I'll sub in, f dash of pi to get e to the pi cos x plus sine x. Cos x will equal -1, sorry, when x equals pi. So you've got -1 plus 0 on -1 squared, and this is going to equal negative e to the pi. So for question 2, it looks like there might be a little bit more working that I have to do because it's worth 3 marks. And it also looks like it's an integration question because there's f dash of x and we're trying to find the original equation. So with this one, the first thing I'll do is I'll integrate f dash of x. So I have the integration of 1 and 2 minus 2x minus 2 dx. And this will give me 1/2 x minus, I know this will be a log because it's x to the power of 1 on the bottom. And since it's a 2, I know that when we're multiplying the log, we'll have to multiply it by 1/2 because it's like the opposite of the chain rule. So we've got 1/2 log 2x minus 2 plus c. Then what I have to do is find what the plus c is equal to, because we've been given that f of 2 equals 0. So if I do f of 2 equals 1/2 times 2 minus 1/2 log e, 2x minus 2 is going to equal 2 plus c equals 0. That gives us c is equal to 1/2 log e 2 plus, minus 1. I forgot the e here. Always remember your e's in your logs. Then from this we can get our final equation, which is going to be f of x is equal to 1/2 x minus 1/2 log e 2x minus 2 plus 1/2 log e 2 minus 1. And I just leave this like that. Okay, so now we're doing question 3. I see it's worth 5 marks and there's 2 parts, and I think the next part is a graphing part. So the first part of this asks us to solve the equation 2 cos x plus 1 equals 0. And I know that there's no multiplier on the x. So because there's no multiplier on the x, I don't actually need to change the domain of this solving. So we'll go 2 cos x plus 1 equals 0. Therefore, cos x equals -1 on 2. And I know for 1/2, the reference angle for cos is pi on 3. And I also know that it's going to be in the second and third quadrants because it's a -1/2. So therefore, cos equals 2 pi on 3 and 4 pi on 3. Next question here is a graphing question. So we've got to sketch the graph of the function f on the axes below, labeling the endpoints and the local minimum points with their coordinates. So here I'm going to make sure that I just have a quick look at this function. So we've got 2 cos x plus 1. So I know that the amplitude is going to be 2. I'm going to write this equation down here actually. So we've got f of x 2 cos x plus 1. And the domain is from 0 to 2 pi I saw before. Yep, 0 to 2 pi. So first thing I'll do is I know cos equations look like this. Oops, look like that. So I know that the point is going to start from 2 plus 1. So it's going to start at 3. And then it's also going to end at 2 pi and 3. And then from the past, from the previous question, we got the x-intercepts. Got 2 pi on 3 and 4 pi on 3. So I'll just write that in as well. And we've got to remember that they ask us to label them. So I'm going to write these down. So we've got 0 and 3. And then we've got 2 pi and 3. And then we've got 2 pi and 3 on 3, 0, and 4 pi on 3, 0. Now, the other thing that I know is that since cos is essentially a symmetrical function, the local minimum is going to occur halfway between the endpoints because it hasn't been moved left or right. So therefore, I know that the local minimum is going to occur when x equals pi, and the minimum of this equation is going to be 1 minus 2, which is going to be at -1. So now, basically just connecting the dots, I'm going to write this in as well. And we just draw this equation. Like that. Yeah, that looks good. I'm just going to check that I've actually done everything I need to do. Endpoints, local minimum, and yeah, these points are included, so they'd be circled in circles. Local minimum with coordinates, yeah. So we've labeled everything. Okay, so now we're moving on to question 4, and this seems to be our first probability question. So we've got x as a normally distributed random variable with a mean of 6 and a variance of 4. A variance of 4 will mean that the standard deviation is 2, and then let z be a random variable with the standard normal distribution. Okay, then they're asking us to find the probability that x is greater than 6. So this one is fairly easy because it's a normally distributed random variable and the mean is 6. That means that the probability that x is greater than 6 is going to be 50%, or 0.5. 0.5. And it's 1 mark as well, so you really don't need any more working than that. Then we're looking for the probability, find b such that probability x is greater than 7 is equal to the probability that z is less than b. So with this question, what we're looking at is the standard normal distribution, and hopefully we should know that z is equal to x minus the mean on the standard deviation. Ignore that terrible Greek writing. But from this, we can hopefully get the value of z that this is equal to. So from that, we can go, and in this one, the mean is equal to 6, and the standard deviation is equal to root 4, which is 2. And I got those numbers from the mean of 6 and the variance of 4. So therefore, the probability that x is greater than 7 is going to be equal to the probability that z is greater than 7 minus 6 on 2, which is the probability that z is greater than 1/2. But then the trick in this question is that it's asking not for the probability that z is greater than, but the probability that z is less than. And the trick to this is realizing that the standard normal distribution is symmetrical with the peak at 0. So the probability that z is greater than 1/2 is also equal to the probability that z is less than negative 1/2. So therefore, and don't forget this step, this is a way you can lose marks, remember to say that b is equal to negative 1/2. Okay, so now let's move on to question 5. This is the first one where we have to work with inverse functions. So the first thing that I'm looking at is they ask us to state the rule and the domain of f inverse. So what I'll do here is I'll be like, let y equal 1 on x minus 2 squared. And this is actually an important thing to do because f of x doesn't have y in it. And when you're solving for inverse functions, you're trying to find it when x and y are switched. But f of x doesn't have a y in it, so you can't just say swap x and y. But now that I've defined y as being f of x, now I can say swap x and y. And then this will allow me, this will allow me to do x equal to 1 on y minus 2 squared. Then just rearranging this, I'll get y minus 2 squared equals 1 on x. Then we can go to the next one, which will be y minus 2 equals 1 on root x. And here I have to decide whether it's going to be plus or minus root x. So I'll just put in the plus or minus really small there. I'll go down to the next line. So y minus 2 equals plus or minus 1 on root x. So the way I decide whether it's plus or minus is that I have a quick think about what this is. And also we know that the domain of the original function is going to be the range of the inverse. And because the domain of f is 2 to infinity, therefore I know that the range of the inverse function, which is going to be y equals plus or minus 1 on root x plus 2, I know that the range has to be 2 to infinity. Let's have a look to make sure. Yep, 2 to infinity. And because the range has to be from 2 to infinity, I also know that therefore this must be a positive root x, because if it was negative, the range would be from 2 to negative infinity, because you'd be doing 2 minus some x number. So therefore, the next thing I have to find is the domain of this inverse function. And the way I'll do that is by having a think about what the range of the original function is. So with the original function, we know that it looks something like this. Oops. Something like this. And where this is an asymptote at 2. And the function goes from 0 to infinity. And that's because it's a truncus. And when x approaches infinity in the original function, it approaches 0. And then when it approaches 2 in the original function, it approaches infinity. So because of that, we know that the domain of the inverse function is going to be 0 to infinity. And the rule is going to be f negative 1 of x. The equation actually is going to be f negative 1 of x is equal to 1 on root x plus 2. And so if we were going to write this properly in the sort of function notation, the way I'd write this would be f negative 1 such that the domain, so 0 to infinity, and then this is the subdomain to real numbers, but that doesn't actually matter. It's always going to be real numbers. And then we have the actual equation, f negative 1 of x equals 1 on root x plus 2. Okay, so now we'll move on to question 6, which is a probability question. We're told that 2 boxes each contain 4 stones that differ only in color. Box 1 contains 4 black stones, box 2 contains 2 black stones and 2 white stones. And a box is chosen randomly and 1 stone is drawn randomly from it. Each box is equally likely to be chosen, as is each stone. Okay, so what is the probability that the randomly drawn stone is black? So this one is a 2-mark question, even though I think it's probably a bit easy for a 2-mark question, but we know that there are 4 black stones plus 2 black stones in box 2, and then 2 white in box 2 in each box. So then there are 8 stones in total. And then both boxes equally likely to be chosen. And then you know that there are 6 black stones in total. So then there are going to be 6 on 8. There's going to be a 6 on 8 probability that you pick a black stone. And from that, you get a 3 on 4 probability that the randomly drawn stone is black. And for this, I might actually write something else a little bit more to make sure that I actually get the 2 marks. So 6 black stones. Six on 8 equals 3 on 4. And then I might just write 3 on 4 probability of choosing black stone. And that will hopefully get me both marks. Next question is that it is not known from which box the stone has been drawn. Given that the stone that is drawn is black, what is the probability that it was drawn from box 1? So this is a classic given that probability question. So we're looking for the probability that the stone is from, box 1, given that it's black. So this gives us the probability that from the probability equation that it's a probability of it being in box 1 and being black over the probability that it is just a black stone. So the probability of picking a stone from box 1 and it's black is going to be 1/2. Because there are 4 and 8 chance of picking a stone from box 1. And if you pick a box 1 stone, it's always going to be black. So we get 1/2 divided by the probability that it's just black, which we calculated above, which is 3/4. And then this gives us the equation, which is 2/3. Okay, so now let's move on to question 7. And now we're starting to get to the harder questions of this paper. But we have, let P be a point on the straight line y equals 2x minus 4, such that the length OP, the line segment from the origin O to P, is a minimum. So what I'll do for this question is I'll probably get the distance equation and then get the derivative of it, and then do that to find the point of the coordinates of the point P. So the first thing I'll do is I'll let the point P be some point. So that will be P 2P minus 4. And this is essentially just the coordinates of any point P on this straight line. Then I'll say distance OP equals, let's call it D of P. So it can be like, let distance OP equals DP, D of P. Then D of P is equal to, and now we use the distance equation. So we get, P squared plus 2P minus 4 squared. And then this we'll just expand that, and that will give us root 5P squared plus, I'm just combining these two. This would be 2 times 4, 8, times 2 again will give us negative 16P plus 16. And then to find minimum, I'm just going to go D dash of P, derive it. So then that will give me 10P minus 16 times, this is a square root, so times 1/2 times 5P squared minus 16P plus 16 to the negative 1/2. And then I know that the minimum, which is what they're looking for, is going to occur when this is equal to 0. So I know then I'll write that D dash of P equals 0. And then that will give me this part of the equation, because I know that since this is to the power of a negative fraction, it will be on the bottom and therefore it can never be 0. So therefore I get P is equal to 16 on 10, which is equal to 8 on 5. And then what I'll do is I'll put that into this equation here to get the y coordinate. So y coordinate (2 times 8 on 5 minus 4, which gives us 16 on 5 minus 20 on 5, which equals negative 4 on 5. And this gives us coordinates of P 8 on 5, negative 4 on 5. Okay, so now we'll move on to part B, and part B asks us to find the distance OP, and this is actually pretty easy now that we have the coordinates of point P. So now we're just going to write distance formula equals 8 on 5 squared plus negative 4 on 5 squared, and this is going to equal root 80, I'll just write it fully, 64 on 5 plus 16 on 5 25, sorry, which equals root 80 on 25. And then what we'll do here is we'll just simplify this square root. So this gives us, we can take out 16 and 25 here, which will give us 4 on 5 root 5, which is 4 root 5 on 5. And that's given away by this sort of hint they give in the question stem. Okay, so now we're up to question 8, which is the second last question in this paper. So the first thing we have to do is show that f dash of x equals whatever that equation is. And we're given f of x is equal to that. So this is just going to be the product rule. So I'll just go through that and check how many marks it is. It's 1 mark, so not much working out needs to be shown. So we'll just write f of x equals x squared ekx, and then f dash of x is going to be 2x e to the kx plus x squared times k e to the kx. And this is just from the derivatives of x squared and e to the kx. And then from here, I might just straight away write what they have here, because I know that they're the same. Next thing they ask for is the value of k for which the graphs of y equals f of x and y equals f dash of x have exactly 1 point of intersection. So what I do here is, I'd look at each of these equations and I'd make them equal to each other to find the intersection points. So the first thing that I know about this is got x squared k, let me make sure I write it down correctly. E to the kx, x squared e to the kx equals x e to the kx, x e to the kx, kx plus 2. Okay, so from here, what I can do is I know that I can actually cancel out e to the kx from these two equations, because I know that e to the power of anything will never equal 0. And in maths, you just can't divide by 0. So this is the only thing that we can actually cancel out. Now from this, I'll try to solve this equation. So I got x squared equals x by kx plus 2. This will give us x squared equals kx squared plus 2x. This will give us the equation x squared minus kx squared minus 2x equals 0. And now we're essentially solving this equation for 0. So we can get x squared 1 minus k minus 2x equals 0. Then if we go across the line, we can get x 1 minus k minus 2 equals 0. And 1 x 1 minus k minus 2 equals 0. And then using the null factor law, we can get x equals 0, and we can also get x 1 minus k minus 2 equals 0. And then from that one, we can get x equals 2 on 1 minus k. And then therefore we know that there'll only be 1 point of intersection when k equals 1, because then this second point of intersection will not exist, because the denominator of the fraction will be 0. So that gives us the answer, k equals 1. Okay, so now we'll move on to the next part of this equation. They give us a diagram and a new equation called g of x, which is negative 2x to the kx on k. And it shows the sections of the graphs from 0 to 2. So they're asking us for the definite integral that gives the value of a. So for this one, you wouldn't need to work it out, I'm sure, I think. So yeah, it would be impossible to work it out. So because it's this shaded area here, we know that it's basically the top line minus the bottom line. So this is gonna be the derivative of 0 to 2, oops, let's write that properly, 0 to 2 f of x minus g of x dx. And then therefore, we'll just write this out. So a equals that, which equals, I've forgotten what f of x is, but that is x squared e to the kx. So we've got 0 to 2 x squared e to the kx minus, this is a negative, so we'll just change it to a plus. So plus 2x e to the kx on k. I hope that's, yeah, I've written that right. We get this. And that will be our answer for this question. Now we've got the next part, which says, using a result from part A or otherwise, find the value of k such that a equals 16 on k. So we want this definite integral here to find the value of k such that a equals 16 on k. So we'll have a look here. We've got the definite integral. So we've got 0 to 2 x squared e to the kx plus 2x e to the kx on k dx. And we want this to be equal to 16 on k. And so since they say using our result from part A, I'm thinking that the answer will probably have something to do with the integration of this, because we don't actually know how to integrate this in methods, but they give us the answer to part A, which looks something like it. And so we work out the integral using this answer. So I've got this part of the answer, 2x e to the kx plus x squared k e to the x. And what I realize is that that is essentially what this is if we took out this k. So 2x e to the kx is actually this part of part A, except I realize that there's a k on the bottom, but then I also realize that this part of this equation has a k here. And if we take the k out of the brackets here in this definite integral, we'd have to add the k to this part as well. So what I realize here now is that we get this, we get 1 on k 0 to 2, because we're taking out this k out of the brackets. So then we got x squared e to the kx plus 2x e to the kx dx equals 16 on k. And now we can actually integrate this inside, because we know that it's actually just the derivative of this. So what we can do here is we can get, the first thing is we can actually just cancel these out. So we get derivative here, I think it was x squared e to the kx. I believe that's what it was. Sorry, let me just scroll up. Yeah, x squared e to the kx. And that's going to be the inside of this definite integral. And then we can put 0 to 2 here equals 16. And now it's just a matter of expanding this out. We get 4e to the 2k minus 0 equals 16. We get e to the 2k equals 4. 2k equals log e of 4. And then we get k equals half log e 4. And that is going to be our answer for this question. So this one is pretty hard. These are quite difficult to do, but once you know how to sort of do it using the answer to part A, then it actually becomes so much easier. Okay, now we're into the last question of this exam. Consider a part of this graph as shown before. And then we're given this question, which is, given that the integral of that equals that plus c, evaluate n pi to n plus 1 pi of that when n is a positive even integer. So essentially what this is saying is n pi to n plus 1 pi is asking you to find the area under the graph from, for example, 2 to 3 pi, 2 pi to 3 pi, or 4 pi to 5 pi. And they're essentially saying it follows a pattern. So what we'll do here is we'll get the integral of this, and we'll essentially just solve it, I think. So integral of n pi, n plus 1 pi, x sine x. This is going to equal, and they give us what this is equal to. It's sine x minus x cos x. And remember that you don't include the c here because it's actually a definite integral. So it has the numbers that we're putting in. So we don't need to include this plus c. Then we've got from n pi to n plus 1 pi. Then I'm just going to sub these numbers in. So you get equals sine n plus 1 pi minus n plus 1 pi cos n plus 1 pi, and then minus sine n pi minus, this is all in brackets, minus n pi cos n pi. So the first thing that we have to realize here is that sine of n pi is always going to be 0 because n is an integer, and sine of 0, sine of pi, sine of 2 pi, they're all equal to 0. And then also that also applies with sine n plus 1 pi because sine of 3 pi, sine of 1 pi, they're all equal to 0. So this is going to be in, essentially the only part that matters is these cos parts. So then what we end up getting is we get 0 minus n plus 1 pi. And then we have to think about what cos pi is going to be equal to. So it's cos of an even number pi. So that's going to be like cos 1 pi, cos 3 pi. And thinking about the circle and the exact values, we know that therefore it's going to be -1. So therefore we get minus n plus 1 pi times -1 minus, and then we've got n pi cos n pi. N pi is going to be an even number because they tell us that it's an even integer in the question. And then therefore cos of an even integer is going to be a +1. So we get minus n pi times 1, just +1, because cos of 0, cos of 2 pi, they're all +1. So then final answer here we get is n plus 1 pi plus plus n pi. And then we'll expand this, we get 2n pi plus pi. Perfect. Then we're told to do exactly the same thing, except when n is an odd integer. So here we can essentially go back to here. So we just go, let's write this in here. So we get n pi to n plus 1 pi of x sine x dx. And then we're essentially copying what we wrote above, which is this whole, that whole equation, which is quite a bit of work, but we'll do that. So again, we know that the sine is going to be equal to 0 because sine of pi is always 0. And then what we have to look at here is about the odd numbers in the cos. So if we're starting with an odd integer and we've got an odd plus 1 pi, then we know we're looking at cos of even numbers. So now this is going to be slightly different because this is going to be cos of like positive pi. So this is going to be cos of 0 pi, cos of 2 pi, cos of 4 pi. And we know that all of these are equal to 1. So therefore we get negative n plus 1 pi times positive 1, because cos n plus 1 pi is going to be positive 1. And then we're minusing n pi, negative n pi. And then cos of n pi, if n is odd, is going to be negative 1, because that's going to be like cos of 1 pi, cos of 3 pi, cos of 5 pi, and those are going to be 1. So now we get negative n plus 1 pi minus, and it's actually going to be minus here, minus n pi. And then that gives us our final answer, which is negative 2n pi minus 1. So I hope that makes sense with all of the negatives. It can be a bit of a brain crunch, but it's just important to think about what we start with, which is an odd integer. And then if we add 1 to an odd integer, that is going to be an even integer. Oh, and sorry, I made a little mistake. It's not 1, it's pi. I make sure I did that above. Yeah, that was right. So the next question asks us to find the equation of the tangent at the point negative 5 pi on 2, 5 pi on 2. So the first thing that I'm going to do is just find the derivative. So we've got dy dx. That is going to be sine x plus x cos x, which we were given before, I think. And then what I'm going to do is when x equals negative 5 pi on 2, I'll find what the derivative is equal to. So that's going to be when that is going to be sine x is cos is going to be equal to nothing. Then we're looking at sine, and it's going to be in the bottom sort of quadrant. So if we draw the thing, it's going to be here because it's negative 5 pi on 2. And then that means that dy dx is going to equal negative 1. Then we're looking to find the equation of the tangent. And we've been given this point. So we're looking at y minus 5 pi on 2. I'm just using the equation that we use to find tangents. So negative 1 x minus, x minus negative 5 pi on 2. And this will give us y is equal to negative x. And that's the equation of the tangent at that point. Okay, next part asks us to think about translation. So the translation t maps the graph of that onto 3 pi minus x sine of x. We've got the translation. Okay, so the way I like to think of these translations is that this thing inside here is going to be x dash and y dash. So then we get x dash is equal to x plus a. And the original equation is in terms of x and y. So as a result, we have to put in x and y into the equation. So therefore, what we're going to be substituting in will be x equals x dash minus a. So therefore, the translated equation is going to be y equals x minus a sine x minus a. And the first thing that I notice here is that there is nothing inside the sign of the translated equation, which means that they've probably done something with like the translation that they've made probably doesn't actually change the equation. So I see that also it is 3 pi in the equation here. So I'm just going to try and think about what happens when a is equal to 3 pi. So when a is equal to 3 pi, we get y equals x minus 3 pi sine x minus 3 pi. And if we think about what x minus 3 pi actually is, sine of x minus 3 pi is, that is essentially the sine equation pulled forwards by 3 pi. And if we think about what it looks like. I'll just draw this quickly. Oops, that's wrong. So if we have, essentially what we're doing is we're moving this point forwards, and then therefore we're going to get negative sign. So what's important to realize here is that sine of x minus 3 pi is actually equal to negative sine of x. And then from there, we actually get y equals x minus 3 pi times negative sine x. And that gives us the actual proper answer, which is 3 pi minus x sine x. And then that tells us that a must equal 3 pi. So I hope that makes sense with the translations. This question is kind of hard to explain because it requires you to know that x minus 3 pi, sine of x minus 3 pi is equal to negative sine x, and also that when you're doing the translations, you're actually getting a x minus the a, not x plus a, even though there's plus in this translation equation here. Okay, so now we're up to the last question of this test. They give us this new equation, which is the transformed one that we talked about before, and also the flipped version of that. And they give us a line L1, which is this line here, and they tell us that it's a tangent to the graph at the point pi on 2, 5 pi on 2, that's here, and that L2 is the tangent to the graph pi on 2, negative 5 pi on 2. And then the question is to find the total area of the shaded regions. So essentially I know that to find the shaded regions here, I need to find the area of these circles, these areas here, and then I need to minus that from the area of this entire triangle. And this actually probably isn't that bad, because what you have to realize here is that this is essentially the same as this first equation that we got given here. So what we're looking at is this part of it. And this has just been moved across to here so that we can actually see the equation properly. And then what that actually means is that we've actually calculated pretty much everything that we need to calculate. So the tangent here is going to be essentially this, but moved up and down. So we can probably find the equations of L1 and L2. So because we found the tangent before, we found that it had a gradient of -1. We also know that therefore with this one, nothing's been changed in like dilation. So there's been no dilation or transformations this way. That means that the gradient of L1 must be -1 as well. And since it intersects at 3 pi, that must mean that this is also 3 pi, because it must have a gradient of -1, and L2 must also have a gradient of 1, because we're told that it's the tangent of the graph of G at that point, which is exactly the same as this tangent we found before. So therefore we know that this must also be 3 pi. So therefore we can find area of triangle, which is going to be 1/2 times the base, which is going to be, that's supposed to be -3 pi, sorry. 3 pi to -3 pi, which is 6 pi, times the height, which is 3 pi again. That gives us 9 pi squared. And then now the last thing we need to do is find these shaded regions. And this, again, we've done earlier in the question, because we were told how to find out the areas of each of these from the positive even integers to the positive odd integers, right? So what this area here, let's call this area A. Area A is actually exactly the same as this area here, I believe. Let me have a look actually. No, sorry, I'm wrong. Area A is going to be this area from 2 pi to 3 pi. Because, and the reason you can tell that is because we're essentially following this equation here. And so it goes up once, down once, up once. So we're looking at this part here, up once, down once, and up once. So we're looking at 2 pi to 3 pi. And then we can essentially use these equations to get the area of those parts. So when the positive even integer is 2 pi, then we're going to get 4 pi plus pi, which is going to be 5 pi. So area A is 5 pi. Let's call this area B. Let's call this area C. Area B is going to equal, and this is the odd one, so this is going to be area B. This is going to be area C. This is going to be area A. This is from pi to 2 pi, so we're using the odd part. So we've got this, which is negative 2n pi minus pi. That's going to give us 3 pi. So area B is going to be negative 3 pi, and then area C is going to be from 0 to pi, and that is going to be just pi. So then now we can find the area of this entire thing, which is just going to be double areas A, B, and C added together. So A plus B plus C is equal, just remember that we're taking the modulus of this, which is the positive, so just 3 pi because it's the area, and areas aren't necessarily negative, they're only negative in integrals. So A plus B plus C, that is going to equal 9 pi. And then we have to double it because there are 2 versions of it. So 2 times that equals 9 pi times 2, which is equal to 18 pi. And that gives us the final area, which is area is equal to 9 pi squared minus 18 pi. Okay, so that is the end of this Methods Exam 1 paper. I hope you found this walkthrough helpful and that you saw the ways I answered questions and that it helped you to figure out how people are getting the answers to these questions when they're doing the papers. If you found this video helpful, make sure to drop a like on the video and consider subscribing to the channel because I'll be releasing the Methods Exam 2 paper soon as well.